So today is lesson 1 of 4. It's the first lesson on patterns and relationships. And today we're just going to go over the basics, very basics of interpretation of graphs, because graphs are often used in patterns and relationships. So when we deal with this section, they often put a graph in the question. So we're going to have a look at graphs, and then we're going to have a look at a relationship. And we also will talk about the dependent and the independent variable. And we'll have some questions at the end of the lesson. Okay. All right. Hope you're ready. Let's get into it. So we're going to quickly run through the basics of graphs. Here we have a pie chart that can represent some information with a pie chart. Now, who can tell me in chat what is missing from this chart? What should you be seeing on this chart? Type in chat. Look at the graph there, the pie chart. What do you normally see in the pie chart?
Numbers.
It says labels.
Very good. Very
The
good.
percentages.
That's the one I was looking for, the percentages. Good, good. All right. Key, or even a key, yes. Label what the pie chart is about. Good key concept. Numbers. Yes, Shanu, that's it. Numbers. Heading, number, percentage carried. Chiamo's got it all. All right. Very good. You all got good answers. Okay. So a pie chart should have a heading. All right. Describing the reason for the pie chart. Very good. You could have a key on the side over here, which explains the different colors and what they are, or you could have a certain color there and a certain color and then a description, or you can have information in your pie charts. All right, so let's say this brown piece of the pie, we call this shape here, this piece of the pie or piece of the pizza is called a sector. So this sector of the pie would have information, for example, like that looks like it's about 95%. No, not 95%, 95 degrees, which would give us just over a quarter, so that'll be about 28%. Let's say 28%, and this one here will be 24%. Okay, and then the green one here, let's make it 12%. And then the blue one, let's see what we got. Let's make this 30%. Oh, people are going to shout at me because the blue one's smaller than the purple one. So let me rather do this. Let's do 22%. Okay. Here is your first question, everyone. If I put in percentages into these sectors of the pie, what percentage is the yellow sector of the pie? The one that doesn't have a percentage in. Let's see, you can get this answer the furthest, the fastest.
That was so quick.
Sure. Okay. 10, okay. Lego looks like it's giving an estimate of 10 or 9. Ompila's got 14. All right, here come the 14s. Okay, 10 for Chiamo. Some different numbers here. Okay, Babala's here on the 10, 12. We've got different answers here. Vivan, 14, 9, 34%. Okay, we got different answers. That's interesting. Let's have a look. Okay, let's try and work this out. Make sure that you got your calculators there. So one way you could do this is by saying that the whole pie, if these are percentages, has to have a percentage of 100%. Okay, I'm just going to write 100 there. And then we're going to take away all the percentages we know to find the one that we don't know. So I'm going to minus, and look how I build this formula. So 100% minus all the ones that I know, which are 12 plus 24 plus 28 plus 22. So that bracket there. So it's 100% minus all the pieces that I know, should give me the one that I don't know. So if I press equals here, 14. All right, well done. 14%. So this yellow 14%. Let me write it in there. 14%. So a pie represents a whole, and each sector represents part of the whole. So this graph is mostly about saying which category is taking up a portion of the whole. Okay, which is a very, very interesting comparison. For example, you could say, if you want to work out how much time you spend on different things in your life, like schoolwork and driving and eating food and watching Netflix and sending messages to your boyfriend or your girlfriend, all right? Which portion of the pie, because it's Valentine's Day coming up, so which portion of the pie it takes up a certain percentage of the whole? You can see with the diagram here exactly which one is the most. Maybe Netflix takes up the big orange piece of 28%. So pie is very useful in comparing parts of a whole. Okay, let's move on to a line graph. Okay, so obviously this is a line graph because it is made up of lines in here. We are representing something with lines. But let me ask you, this line graph is a special type of line graph. Can anyone tell me what type of line graph it is? It's not just a line graph. We get lots of different types of line graphs. Who can tell me what type of line graph this is? Anyone in chat? Easy as pie. Non-linear. Okay. It's a good answer. Non-linear. Linear. Linear. Exponential. Okay. Some good answers coming out here. Linear. Linear, linear, linear. All right. It looks like we've got lots of linears from now on. All right. Exponential and non-linear. All right. Umpile. Come on, man. Let's get your microphone off. Can you tell us why you said that this is a non-linear? I'm very interested to know.
I don't know about you, Dale, but I'm excited to hear the Australian accent.
Can't wait. I've been waiting for this the whole time. All right. I don't know if he can turn his microphone off. Come on, Upile. Talk to us, man. Don't be shy. I'm interested about your answer. Non-linear. Scattered. All right, the points are scattered, yes. Sonia, non-linear. Upile, can we hand over to Sonia? Sonia, do you want to try and explain to us why you say non-linear? You're welcome to turn your microphone on.
When Pila says they're shy, can they please type? And then Sonia says the line is not straight.
Why are you guys being shy now? Why are you being shy? Don't be embarrassed. You just want to talk. We get lonely on the other side here sometimes. The line is not straight. Okay, that is a good answer. All right. So I think a lot of people are answering saying linear because it is a line, and the word linear has the word line in it, and linear means a line. We're going to see later on a couple of examples of linear graphs. You get different types of linear graphs. Okay, so if I draw you a quick example, we get a linear graph that goes straight up. We get a linear graph that goes straight horizontally. We have linear graphs that also go in the other direction like that. So those are all examples of linear graphs, line graphs like that. This is a line graph, but the linear relationship, so that word linear is attached to the word relationship. We're going to have a look at that on Thursday. Now, we can't really see any relationship here. Someone's answer said it was scattered, okay, which is actually referring to the points on the graph. The points are scattered, all right, and we're trying to join the points up with a line. So the correct term for this is a broken. It is non-linear, a non-linear graph, but it's also called a broken line graph, because it's like taking a line and then cracking it, breaking it in different parts of the line. Okay, so it's a line. It was a straight line, but we've broken it, and now it's got these different angles in it. Okay, well done on Pila, yes. Okay, let's have a look at the next one. All right, we have a bar chart, an average looking bar chart. Okay, there's no labels on the Y or the X axis. We just got ABC on the X axis, and we have numbers going from 0 to 80 on the Y axis. Now it's called a bar chart, but it's not just a bar chart. This has got another name for it, a more detailed name than just a bar chart. You can tell me what type of bar chart it is. We need to come back to this histogram. So some non-linear graph. The important is a non-linear graph, but we call it a broken line graph. Histogram. Very interesting, Akia.
Yeah, no, there's very different answers.
Yeah. Right, Pavalo, definitely is a bar graph, but it's a special type of bar graph. Bar line. Sonia, yes, that a bar line graph would have a bar and a line on it. Yes, Kamal, histogram is different to a bar graph. So it's either a bar graph or it's a histogram. There we go. Bar graphs, well done, Guyo. Bar graphs have spaces, histograms have no spaces. Are there spaces between these bars here? If you look at the graph again, we definitely have spaces over here, okay, between these categories. So this cannot be a histogram. Some people need to try again. It's a type of bar graph, but what type of bar graph? Has Umpilo answered yet? He's thinking. He's thinking. Well done, Umpilo. Histogram. All right, Awande Zoni number 1, because we've got 2 Awande Zonis in this class. Cannot be a histogram because it's got spaces between category. There we go, Sonia. There we go. Compound bar graph. Well done. Compound bar graph. Okay, compound, the word compound means lots of, many of. Okay, so compound. A compound bar graph. Okay, and some people, if there were only 2 bars, like a blue and a yellow bar in each category, like category A, category B, category C, if there were only 2 bars, you could call it a double bar graph. Okay, but if there are more than 1 bars, especially if it's 3 or more, you could say a compound bar graph. And the word compound means many bars. Okay, very good, Sonia. Well done. Good. Okay, so those are the basic graphs that you'll see in this section. They often put a graph up or a chart up in this section, and they ask you to answer a whole lot of questions. Okay, so we will be doing that. But you need to know the basics of these graphs and recognize them and when they are going to be used. We'll go into that a little bit later on. Let's move on to the dependent versus independent variable. Now, please do not worry about the word variable. Okay, this is core maths, this is math literacy. We don't use variables. Okay, so don't worry about the word variable. But we use this word to help us explain dependent versus independent. You're not going to see any variables, promise you guys. All right. So we have a relationship here, or a pattern, should I say. We have a matchstick pattern. You've seen this before many, many times. It's a matchstick pattern. We have pattern number 1, pattern number 2, and pattern number 3, and then there's a space for pattern number 4. All right. So now it's your turn to work. We're going to talk about this, but I first need you to complete this pattern. Question 1 says, draw the match diagram for pattern number 4. So you're going to draw it in your pen and paper, and then I'm going to draw it, and then you're going to give me the thumbs up if you got it, or the thumbs down, or if you don't have to say anything if you don't want to. But let's see what you guys draw. All right, I'm going to give you a chance, give you a minute or 2 to draw those matchstick diagrams for pattern number 4.
It was so fast. They got it already. And Kamo.
And Kamo, there we go. Yes, Pabalo, that's it. You're on the money. Good, we're going to talk about that soon. All right, if you've got a pen and paper, I'm sure it'll be quite quick to draw pattern number 4. Okay, so I'm going to start drawing it now, and then you can have a look and tell me if you get something similar. All right, so now I'm like Pablo Picasso here. All right, there we go. On the screen is pattern number 4. You guys should all have it. Thumbs up if you do. Well done, got it, good, got it, well done, guys. Okay, quite easy to do. Yep, got it, well done. All right, let's continue with this little exercise. Now, what you've just done now is a common question in the exam, is for you to complete the pattern by drawing the next pattern in the diagram over here. Just remember to draw it with pencil. Please, guys, draw with pencil. You're allowed to draw with pencil. In the exam, if you draw with pen and make a mistake, it gets really, really messy. So please always use a pencil when you draw. All right. Let's have a look at this now. So we can express this pattern in a table form. So often in patterns relationship, there is a diagram, then there is a table, a graph, and sometimes even an equation. Okay, we'll talk more about the equation later on. We've got the diagram here. Now we're going to transfer this information into the table. All right, so here's the table over here. Okay, all this information here. So what I'm going to do is I'm going to ask you to please answer question 2, which says, determine the values for A and B in the table above. Determine the values for A and B in the table above. This table relates to the matchstick pattern. All right, so please complete the table, calculate A and B. Well, first Jordan got them both already.
Such fast fingers, I like it.
Very fast fingers today. I hope that calculator is doing the work.
Kamkhelo, please mute.
All right, looks like we've got some answers here. There we go, there we go. Answers are still coming in, very good. Okay. All right, there we go, good. It looks like everyone's getting the idea. Okay, let's have a look at this in a little bit more detail now. I'm going to zoom in. Now, I want you to bring to your attention something that's very important in the exam. When they give you a table like this, and I can see you guys understand this, the first thing you look for is, and it was given to us in the matchstick diagram, that there was a change for every pattern number, all right? So as we jump from pattern number to pattern number, we're trying to figure out what is the change. Okay, that's important. And what we see here, let me quickly make some space, is that every time we move from one pattern number to the next, like from 4 to 7, we are increasing it by 3. Then from 7 to 10, we are increasing it by 3. And then from 10 to 13, we are increasing by 3. Okay. Now, because of this pattern, what you guys did was you inferred, you used the word infer or deduced, that the next number in the pattern, which was this one here, had to have the same change. Okay. Which means that you would have said from 13 to B is plus 3. All right, so I think that's how some of you guys did this, was you worked out what is the change every single time, and you said, well, there must be the same change from this pattern here, which has an A in it, pattern number, and pattern number 5. You said it must be the same change. So we're going to add another 3 there to get a value of B, which is 16. Okay, so I'm going to put 16 over there. Now, I specifically wrote this question and I used the word determine. Okay. And you've got to pick up on the words in the exam because the words that they use in the questions often give you a hint. So when they say determine, this could be through calculation or any means necessary. All right. And you guys must have done that. You must have done a common difference and found that the common difference is 3 and then moved on to the next one. Well, what if I had said calculate? We'll come back to that now. They could have used the word calculate and say, in fact, sometimes they do. All right, let's go back to number A. So you said, well, there's a difference of 1 every time. 1, 2, 3. So the next one obviously is 4. And you said that A is 4. Okay. So you used the pattern and the fact that there was a constant increase to help you solve this, to determine the answer, which is absolutely fine. Okay. Now, your methods are fine, but I'm just giving you a warning now. Be careful, because sometimes they will try and trick you. Instead of a 5 here for the 5th iteration, the 5th number in this pattern, they could put 12. Now, I know what you're thinking. It's fine, sir. I'm going to keep jumping. I'm going to keep jumping. I'm going to go from the 4th one. I'm going to jump another 8 times to get the answer for B. So I need to go from 4, jump 1, 2, 3, 4, 5, 6, 7, 8, and then you'll end on 12. Okay. If you jump 8 more times and you increase this number by 3, 8 more times, you'll get the answer for B. That's fine. That's determining the value, which is absolutely fine. What if they put the number 127? Well, then you're going to be doing a lot of jumps to get to that answer. Okay. So what we also want to learn is how to work this out without just jumping from one to the next. Because if they don't put everything in the correct order, if they jump a couple of numbers, then you might come a little bit unstuck. So your answers for A and B are absolutely correct. You have
please stay muted.
Okay, let's continue there. Pabalo. This is what I'm talking about. You must find the rule. Now, it's good to find the rule sometimes, because sometimes they give you a pattern that isn't always consecutive, and then you might get unstuck. So I'm also going to show you how we find that. Sonia. Sonia is talking about, yes, that is a very special pattern rule. We're not going to use variables. Remember I said the word variable early on. Okay, I'm going to try my best. This word here, variable. We don't really like this word in math literacy. We try not to use variables. We're going to avoid it at all costs. Okay, so I'm also going to avoid it at all costs, because that's core maths. We're doing the fun maths. All right, so we don't want to work with variables. We want to try and stay away from variables. But yes, that is a similar rule. Okay, we're going to work with this rule. All right, but let's have a look here now, because we can actually plot this relationship. All right, so on my screen here, I actually have a graph which plots that table onto a chart or graph paper here. So for pattern number 1 down here, the number of matchsticks was 4. That's the first one we started with. I'll go up there. For pattern number 1, there were 4 matchsticks. Okay. So now for pattern number 2, how many matchsticks did we see? Well, we saw 7, right? So what I can do is show you guys that if we go from 2 up on this graph, and from 7 to the middle over here where these 2 lines touch, this point here is another point to plot on the chart. Okay, that gave us 7. For 3, we had 10. For 4, we had 13. And for 5, we had 16. Okay, so we can actually plot all of these points in the table. These are plotting pairs. All of these points are plotting pairs, and we can actually plot them onto the graph. My question though is, which of these things, the pattern number or the number of matchsticks, which one goes where on my graph? I mean, I've done it for you, but what if they asked you to do this from scratch? How are you going to know which one goes where? Which one goes on the x-axis and which one goes on the y-axis? All right, now to understand that, we need to understand the relationship between the dependent and the independent variable. Okay. Yes, Sonia, that is true. So we got to work out which one is the dependent and which one is the independent variable. All right. So what I'm going to do is to go back to the table here, and we're going to have a look at these again. Okay. Now, who can help me here? Someone please help me tell me which one is the dependent and which one is independent. Guys, please turn on your microphones. would love to hear your voice.
The pattern number is
independent.
Who was that?
Me.
Who's me?
Aballo.
Ah, thank you so much. All right. So you said the third. What that means is that one of these numbers relies on the other one. You can't have, for example, the matchsticks here. Okay, if you don't have a number, pattern number over here, if you just have a question mark for this last column over here, if you don't put a value in there, I can't tell you how many matchsticks you've got. Okay, so to determine the number of matchsticks, you have to give me the pattern number. I can only work out the matchsticks if you give me the pattern number. Okay, all right, so the number of matchsticks depends on the pattern number. All right, so the number of matchsticks depends on the pattern number, which means it's the dependent. All right, so the matchsticks here depend on the pattern number. You can't get the number of matchsticks without knowing the pattern number. They depend on the pattern number. All right, so it's the dependent. Okay, the pattern number doesn't matter how many matchsticks you've got. The pattern number can increase and do its own thing. So the pattern number is independent. All right, it doesn't care how many matchsticks there are. It's just going to change. But the matchstick number relies on the pattern number. Okay, so now which one do we put on the graph and where do we put it? So the pattern number, which is independent, goes on the x-axis. All right, and usually the dependent variable, which is the matchsticks, goes on the y-axis. All right, so the dependent is on the y-axis and the independent is on the x-axis. So the pattern number doesn't care how many matchsticks you have, but the number of matchsticks, you can only find that if you tell me the pattern number. Otherwise, I can't find it for you. All right. So that's how we work out the dependent and the independent. Are there any questions? Does anyone have a question?
You can comment on the chat, or you can just ask, raise your hand and I'll unmute you to ask your question.
Yeah, we love it when the guys chat to us. All right, Phyllis. So Phyllis says dependent is horizontal. Okay, so the dependent on my graph here is the vertical one. So it's the y-axis, which is vertical. That's going up and down. And the independent is the one that's horizontal. Okay, so you just got the words horizontal and vertical mixed up there. The independent one that doesn't really worry about anyone else, it's going to do it. It's just going to increase on its own. Is the one that's on the x-axis that's independent. It's not worried about anything else. But the dependence, which needs to know what the other number is to work out its value, is the matchsticks, and that goes on the y-axis over here. Okay, so this y value will change depending on what your x value is. So we need to know the pattern number first, and then we can tell you how many matchsticks there are. Okay.
Sonia is asking, is it necessary for it to have a title,
Yes, Sonia, I'm glad you asked that. It's always necessary to have a title. Always, always, always have a title. Okay. You need a title for the whole graph to tell us what it's for, the reason for the graph. And then you need to have labels on your y-axis and labels on your x-axis and units described on your y-axis and x-axis if needs be. Okay, we don't have units here. Matchsticks are not a unit that we work with in Matlit, so we don't need units here. We just got numbers. Okay, are there any other questions? All right, any other questions? Anyone wants to unmute and talk to us about this so far? Is everyone happy with this? Are you all good? Have you got your ice cream ready for after the lesson? So what if it was the other way around?
Vivian, would you perhaps like me to unmute you so that you can clarify for us what you mean by that?
Yeah, Vivian, tell us what you mean. So what if it was the other way around? Come on, Vivian, talk to us. What do you mean? Anila, you raise your hand.
Sir, I wanted to ask if a graph doesn't have to start with 0.
No, it doesn't have to start at 0. Not every single graph, good question. Not every single graph has to start at 0. Okay. Now, I see there's Al Zondi also asked the same thing. Why should this not be at 0? Okay, it's a very good question, and I'll explain why. So if we go back up to our table here, all right, hold a second. I'm just going to quickly close and open this, and then I can explain. All right, so if we go up to our table over here, in patterns, when we have diagrams like this, pattern diagrams, and when you work out, especially when you work out the equation for this, we don't really deal with a 0 with pattern numbers like this. So if you've got matchstick patterns and diagram patterns, you can't have zeros or negatives. Okay, we can't have negative matchsticks. All right. In certain number patterns or in certain relationships, especially if you give an equation and not a diagram or stuff like that, you could prove why you could get a negative answer. But for you guys, with these kinds of patterns, they always start at 1. Always, always, always start at 1. So when we graph them, we'll always start with the pattern number of 1. Okay. Now, this graph did terminate at 4 here. So we could have, if we wanted to, show the 1. We could have extended this graph a little bit more. I can do it for you now. So I could have drawn further down. All right, to a 2 and then a 0 over here. But this pattern will never, ever show a 0 value. Okay, so you'll see how this blue line starts at 4. Patterns usually don't ever start at 0. These diagram patterns like matchsticks and triangles and things like that. All right, graphs do start at 0, but pattern graphs don't normally start at 0, so we don't have to show the 0. All right, they could have shown it here, but there's a reason why we started this one in the corner there with 4 and 1. Okay, we never ever show a 0 pattern number anyway. It always starts with 1. Good question. When you don't start at 0, we'll deduct marks. No, truly, they won't deduct marks. They won't deduct marks. In fact, they'll probably give you the x-axis value for and starting at 1. But if you see, you are plotting with Sonia, I'll answer your question now. You are plotting these coordinates here. So you're plotting these points. This is the first point to plot, which is 1 and 4. Okay, so even if your graph started at 0, you could never go to 0, 0 on this graph because the first number that you're plotting has an x value of 1 and a y value of 4. Okay, or an x-axis value of 1 and a y-axis value of 4. So you can never ever start this on 0. You just plot the points that they give you in the table as you see them. Okay. All right. Let's move on a little further.
We have administrator whose hand is up.
Who's administrator? What kind of a name is that?
I've been asking for administrator's name for quite some time now.
All right, administrator. Sonia, yes, it is proportional. All right, administrator, please turn your mic on and tell us. What question do you have?
Hello, I'm not sure why am I administrator, but I'm Lutando. Sorry, I just want to ask if we say a pattern number is independent and a number of matchstick is dependent,
Yes.
does it mean a pattern number can go up to 100 and a number of matchsticks will follow into that? What does it mean?
Yes, that's exactly what it means.
Oh,
So
I thought I understood. Right, okay.
You've got it. So
All right.
you can only determine a value for the matchsticks if you give a pattern number first. So what you should be doing is drawing the x-axis values as far as you want to, and then once you've got the x-axis values, you can determine or calculate how many matchsticks you have, but you can't work the other way around. Okay, now when you draw the graph, you usually draw it from data in a table. So we could take this table further, all right? And I wanted to do this at the end, but in fact, we'll do it at the end still. So I could take this table further to determine the matchsticks for pattern number 6. A lot of you guys determined that you just need to increase pattern number 5 by 3. We got 16 for B. So 16 plus 3 means that pattern number 6 has a value of 19. Now, we can't calculate or determine this 19 value unless they tell us what the independent value or the pattern number is. So that's what it means to be independent. So the pattern number is independent. It's going to grow on its own, and it's not determined by the matchsticks. It does its own thing. And the matchsticks values can only be determined if you first give the pattern number. Okay, and I'm going to show this in an equation at the end here. There's a very interesting question. I've got the man sweating, the picture of the man sweating here, because when we say the word equation, everyone gets squared. Sorry, it's not squared.
That's a good joke.
Everyone gets squared. Everyone gets scared. All right, you don't have to be squared. Okay. All right. First of all, who can tell me the name of this graph? What type of graph is it? I know everyone's going to say linear. It is a linear. Mpile is an expert. I know he's going to answer this one. What type of graph is this? Yes, it is a line graph. Very good. It is a line graph. It is linear. Increasing. Good. That's a word I was looking for. Increasing.
It's just missing one word.
Yes. All right. We've got it there. Data line. Okay. Yes, it is a line that's representing some data. Good. Straight line graph. Yes, straight line. Continuous. Yes, you could say it's continuous. It will increase. Constant. Ah, there's the other one.
Oh, yay!
Direct proportion. There we go. All right. So yes, it's a graph showing direct proportion. The relationship is a direct proportion relationship. Very good. Okay. And it's a constant increasing graph. Okay, so it's an increasing linear graph, which is constantly increasing. All right, so the words constant, linear, increasing are very good. Yes, it's a direct proportion, showing the relationship is in direct proportion. Very good. We're going to have a look at that on Thursday. Well done, guys. Yes, these guys are clever. Very, very clever. All right. Now, this is the part where everyone starts sweating, okay? Can we build an equation to show this relationship? Now, someone needs to be brave and help me build an equation, please, because I'm sweating and I'm stressing out here. See, when I use the word equation, everyone starts stressing. Who would like to?
Ompile says, oh, I wanted to say it is commonly drawn to show information that changes over time.
Yes, that's correct. Well done, Ompile. That is correct. A constant change, and the change is specifically an increasing change. So it's constant increase. There's a linear graph showing constant increase or direct proportion. Okay, who would like to turn on their microphone and help me? I need help with this one, guys. Please don't make me do it on my own. Oh, come on. Somebody.
Anybody. Somebody.
Somebody.
There we go again,
Somebody.
being silly.
Oh, guys, please don't make me do it on my own.
Ompile is nervous. Maybe you can type it in the chat for us.
Or type it in the chat on Billy. You don't have to put your microphone. Man, I don't know. I love you.
Sonia's scared. Everybody's
Oh,
just so shy.
Everyone's shy. Why?
I thought we're family now, guys.
Don't be shy. We're used to each other now. We know each other. Oh, okay. No, actually, please don't worry. You know what's important is attempting your attempt and trying. Okay, that's the most important thing, and being brave. All right, it's not about getting wrong. Learning is not about getting things right or wrong. Learning is about trying and understanding. Okay, so if you try something and then you get it wrong, it's like, okay, well, why did I get it wrong? What's the difference? And if you see what the difference is and where you should change it, that's part of learning. Okay, so you can't learn if you don't try.
Vuyo says it's 4 plus 1 multiplied by 2 is equal to 7.
Okay. Vuyo, we're getting onto something now. All right, so Vuyo's putting numbers in here to get, that is an equation. So this is what Vuyo says. So he said 4 plus 1 times 2 is equal to 7. Okay, I think that's what he's saying.
Yes.
And I think right, so then this must be pattern number 2. All right, that's very close. This is very close. We're getting somewhere now. We're getting somewhere. All right, let's have a look. We're getting somewhere close with this one here. So this is the answer for pattern number 1, I think. No, it's pattern number 2. Okay, so he said to get pattern number 2, you multiply by 1 and then you add 4. But I think adding 5 here would get you the 7. 2 times 1 is 2 plus 5 would get you 7. So that's a possibility there to get 7. So what Vuyo is doing, all right, Chiamo says multiply by 3. So we're going to have a look at this. So what Vuyo is doing, let me explain here because it's actually very important, is Vuyo is putting in a value here to get out a value over here. All right. So this value on the right-hand side, yeah, right, this value on the right-hand side depends on what is inside this bracket. Okay. If you change what is inside the bracket to another number, the value on the right-hand side will also change. So this value on the right-hand side will depend on what is inside this bracket. So this 2 that's inside the bracket doesn't care what's out on the other side of the equation. The 2 doesn't care if the 7 is there or not. It just wants to be a 2. But the 7's value is determined by the 2. So the 7 depends on the 2. So on the right-hand side here, we have the dependent. Let me write in blue. Because the value of this dependent depends on the 2. And the 2 is independent. Okay, so this 2 is independent and the 7 depends on what the value of the 2 is. All right, yes, we're on to something here. Okay, let's remember that. Now I'm going to move all this down slightly here. And I remember seeing someone say multiplied by 3. Okay, now let's have a look. Let's go back to our table now. We're going to get the answer from our table. I'm going to show you. All right. We know which one is dependent and which one is independent. Okay. And you guys, when you answered question 2, you have to get B value of 16 and A value of 4. I know for a fact you all did this in your head. You said, what is the constant difference? Okay. And you said the constant difference is it's increasing by 3 every single time. Okay. Now I'm going to use pattern number and matchsticks. All right. I'm going to use those words to explain my equation. I'm going to use words. In core maths, they use variables. We're not using variables. Okay. So matchsticks, to get your matchsticks, you have to do something to your pattern number. I'm just going to write pat number. All right. We have to do something to the pattern number. That's something that we have to do is represented by this constant difference here. So when you're increasing by 3 here every single time, what you do to your equation is you say you take your pattern number, I'm going to put it in a bracket there, and you multiply it by 3. Okay. And that's what this young learner has done over there. They've put the pattern number in the bracket there and multiplied it and added something to it. Okay, so I'm going to do something similar. I'm going to take the pattern number and I'm going to multiply it by the 3, which is the constant difference that we had in our pattern. All right, we're adding 3 every time. So I want you to put the 3 in front there. Now, we're going to test this. Let's test this out. How many matchsticks will I get if the pattern number is 1? All right, let's go look at our answer, what it should be. It should be 4. We are getting 3. So there's something wrong with our equation. How can we change our equation to get an answer of 4 instead of what we're getting right now, which is a 3? Can anybody tell me in chat, what can I add to my equation here? Because right now it's 3 times 1, which is 3, but I need 4. Anyone tell me, what do I need to do to my equation? Add 1. There we go. All right, we need to add 1 to this. Okay, so put a +1 here. Let's test it. If the pattern number is 1, 1 times 3 is 3, plus 1 is 4. That is what we should get. Let's test it with pattern number 2. Okay, what's 2 times 3? 6, plus 1 is 7. Yes, it works. Let's try pattern number 5. Now for B, we should get 16. So for pattern number 5, we should get 16. Okay, let's test this thing out. So let's put a 16 in there. 16. Well, I'm using a calculator. I'm feeling lazy. All right, so 3 times 16. The calculator will do the work. Plus 1. Oh, we're doing it the wrong way around, aren't we? So 16. Yes, that's the answer. All right, 5. Well, sorry, my apologies. We're doing it the wrong way around. We need to put a 5 in here. Let's put a 5 in here. The answer must be 16. Okay, so put 5 in there. I'm not too late. So I can do this one. So 3 times 5 is 15 plus 1. That gives us 16. So that works. Okay, so how do we do this again? I'm going to just remind you. All right. So inside here in this bracket is the pattern number. Okay, what do we do to the pattern number? We're going to multiply by the constant difference that we see, which is +3, a positive 3, not add on 3. It's positive 3. So don't say +3. We need to say multiply by a positive 3. Okay, and then you need to add on 1 here. Now I'm not going to use a variable like x or n or anything like that. I'm just going to put a bracket there, and inside here we can say pattern number. Okay, so the pattern number is independent. It's not worried about how many matchsticks there are, but the matchsticks depends on what pattern number you have. So this is dependent. Okay, now if you didn't understand how we got this formula, please do not worry. We're going to practice this. I just want you to touch on this today. We're going to practice this in the lessons that are coming up. Okay, the answers are there. Are there any questions before we end the lesson? Are there any questions? Oh, everyone's gone quiet. I think everyone's eating ice cream here.
Yeah, no, hey. They got a break freeze from the ice cream. Dave says, I wish. Ava's eating pizza.
Oh my goodness. Don't say that to us.
I deserve such nice things.
How do we get the 3? All right. Elzondi, how do we get the 3? Good question. Thank you for the question. All right. Okay, let's have a look. So you go to the pattern and we see how the matchsticks are changing. So we said from 4 to 7, what is the change from 4 to 7? It's going up by 3. You're adding 3 on every time. Okay, so it's increasing by 3. From 7 to 10, we increase by 3. From 10 to 13, we increase by 3. So there's definitely a constant increase of a positive 3 every single time. Okay, and that positive 3 gets put here in front of the pattern number. Okay. Lutando, yes, raise your hand. Please turn that mark off, on, sorry.
Okay, no, I just, my classmates asked, how did you get a 3? And I'm just coming from a drawing. I discovered that we got a 3 every time you need to add on a pattern. And then I counted the mesh sticks. It's always 3 mesh sticks to add into a pattern being a 4th pattern.
Very
It's
good.
always a 3 mesh sticks, yeah.
3 mesh sticks more, absolutely. So in the diagram, we saw that we changed the pattern by adding 3 matchsticks on to every single pattern. So for pattern 1, we had 4 matchsticks. For pattern 2, we had 4 plus another 3, which gave us 7. And then for pattern number 3, we had the 7 for pattern number 2 plus another 3. So 7 plus 3 is 10. And that data is shown here in the table. So if you look at the table where it says matchsticks here at the bottom, we can also see the change every single time. So from 4 to 7 is an increase of 3, from 7 to 10 is an increase of 3, etc., etc., etc. Okay, and that 3 needs to be put in front of the pattern number because you're going to multiply by 3. We're not adding 3. Don't think of it as plus 3 plus the pattern number. It's a positive 3 multiplied by the pattern number. Yes, Janu, turn your mic off. Tell us your question. What? I'll tell you now, Janu. I'll tell you why I was eat question. Eat ice cream now. I just got a question by Flamedi. B. All right, B in the table. How do we find B? Good question. Well, now that we have an equation, it's easy to. But let's do the same method that everyone else did. So they said to get from the 4th pattern, so A is 4, to the next pattern, we follow the same constant increase, and we need to add 3. So 13 plus 3 will give us 16. So B's answer is 16. Okay. All right. Ladies and gentlemen, we're going to end it there. We hope to see you all on Thursday. Sonia, the ice cream, when we started the measurement course, I think it was the 2nd lesson or the 3rd lesson, Kia. I can't remember when it started being hot. I think it was like the 2nd one. The 2nd lesson of the 1st course that we had. There was a heat wave across the country. And I remember Durban was just ridiculously hot. And when we were talking to people in the lessons in that 1st week or the 2nd week, we were saying, guys, we need ice cream. This weather is just ridiculous. And everyone was saying, yeah, no, we need ice cream. This weather is crazy. So since then, we've just been saying, make sure you eat your ice cream after the lesson.
It's a little inside joke, really. Yeah. Alzondi is asking, sir, what if the constant change wasn't constant? Will it affect the whole rule?
What is a constant change and what is a constant? Will it affect the whole rule? So if I'm correct, if I understand what you're trying to say, the constant change is this value that you keep increasing by. Because those numbers are all the same, plus 3, plus 3, plus 3, it's a constant, it's a change that is always changing by the same amount. So it's called a constant change. The change doesn't change. I don't know if you can say that the change doesn't change, but it's the same value over and over again that is increasing by. And that will affect the rule. So if that change was, if this change up here was plus 4, plus 4, plus 4, plus 4, then we would put a 4 down here in the equation in front of the brackets where it says pattern number. Okay, so that constant change, the value that it's increasing by every single time, goes in front of this bracket here. Okay.